This talk is less about how to do CDCR in terms of nuts and bolts configuration, more about which method is best for your use case, why you would use one over the other, and if you are interested in specific nuts and bolts, exactly how do you configure CDCR, there are a number of very specific talks available, even one from recently this year by my friend Amrit, who did a great job going through the nitty-gritty details, and that's available online. I have links in the deck that I think will be available for download from Lucidworks. So cross data center replication use cases. The far and away most common use case is disaster recovery. We want a copy of the data that we have someplace safe so that in the event of some catastrophe, you can cut over to your disaster recovery data center and continue to run. That's far and away the most common reason. Load distribution is another one. I just have too many users and I want to split out my data across multiple data centers so that I can just basically distribute the load. Local positioning of data is done because, say I have an East Coast data center and a West Coast data center and a Europe data center. I want to send local users to a local data center so they get the fastest response time for whatever their query load is. So that's another common use case. Data security is a fairly common use case where I need to isolate a copy of my data for a certain user base that's isolated, but it needs to be the same as what the rest of my users are using. But there are reasons we need to sometimes keep it separate. There's another use case for replication, which is merge and partition replication, which are variations on the traditional replication theme, and I'm going to actually get into a use case in a minute. But basically, merge replication is where you've got data in multiple places and you want to aggregate that content into a single repository somewhere. And partition replication is the reverse of that, where you've got data in a single repository and you want some of it to be replicated to A, some to B, some to C. So here's a use case. A typical customer example, and this is one that I worked with about a year ago. The customer had cluster A, they had cluster B, and they had cluster DR for disaster recovery. And what they were doing was they were crawling all the data they wanted into A, and they had an exact replica crawl running into B, and a third replica crawl running into C. Well, of course, you're crawling all your data 3 times to get 3 copies of it, which both seems and actually is inefficient because you're pounding the servers that you're crawling to get your content. So obviously the answer is, well, why don't you just do that one time, index all the data into repository A, and then use CDCR of one form or another to copy it to B and to C, to the DR cluster. And so that's what we propose. And then they had, in this particular use case, this isn't true for every use case, but in this particular use case, the users would had the ability to query any of the 3 clusters. And normally that's not a problem. That's actually exactly what you want to be able to do and be able to get the same answer from each one. There was a slight complication though, and the complication was that because this was a Fusion environment, Fusion has a really great capability, which is a signals collection, which allows you to record when a user comes and asks a question or submits a query. The fact that user queried that particular location, that particular data center, gets recorded. And that's awesome, except if they query A today and B tomorrow, then the artifacts of the queries that they made get split between the signals collection on A and the signals collection on B, so you don't have a whole picture. And if you want to be able to boost your queries according to what the user activity is, well, you've got your signal data split across your various data centers, and you don't have a complete whole picture. In particular, the pink collection is the query aggregation collection, and that means the raw signal data gets rolled up into the aggregate, and it's the rolled up aggregate that get used for query boosting. So we were getting not fully complete boosting results in this scenario. So what did we do? So the proposal was that we create a master signal, master collection for raw signals that all of the individual data centers pushed their signal data to. And this is an example of merge replication, where you've got some from each of 3 different sites pushing into a single whole master collection, and then we would aggregate at the master level, and then of course the master aggregations get replicated back down, and so there's no aggregation going on at the individual cluster level. So that's the real life scenario that we were faced with, and so let's talk about the options that were available in terms of how to solve the problem. First of all, Solr CDCR is it's a fantastic capability. It's been in Solr since Solr 6. It's gets improved with every revision, and you know, like any new capability in Solr 6, it was there, but it had bugs. And like every piece of software has bugs, but it's solid, and it's production ready. And especially now since Solr 7.2, so a lot of issues have been worked out, and with now Solr 7.5, anything from 7.2 on, I would personally strongly recommend for production use. So what does Solr CDCR do? It makes a complete copy of all the documents in the collection. It is defined at the collection level, but it operates at the shard level. So each shard is replicated separately. So which is why best practice is that you mirror the sharding environment and the configuration environment on both sides, from the source to the target. If you've got 3 shards on the source, you should have 3 shards on the target. And whatever your configuration set is on the source should be the exact same configuration set on the target. There are ways to make it work if those aren't exactly the same, but you're making it harder for yourself, and it may not be the right use case. So Solr CDCR does support bidirectional replication, but not simultaneously. You can replicate from A to B, and you can stop it and turn around and replicate from B to A, but you can't have them going on at the same time. You have to choose. It is push-oriented, so you define at the source where it's going to go. You can define multiple targets if you want to, but it is push-oriented, so the source does the work as opposed to the target pulling. It's batch-oriented, runs on a timer, by default 1 second, and that allows it to bulk move contents so that you get the most efficiency possible on the line. And basically, it forwards the transaction log. So first, the document is committed to the source, and then the entire document that you just committed gets put on the wire in a queue for transport to the target or targets. And that document gets reanalyzed at the target So if whatever fields you're indexing, whatever fields you're storing or not storing, all of that happens again at the target as if the target was seeing it for the first time. So what is this solution best for? It's great for disaster recovery scenarios. It's great if you need a complete replica of a full collection, all the documents, not just some of them. If your schema and your sharding are identical everywhere, this is a great solution for you. If most of the time you know you're copying from A to B, this is a great solution. If you have good connectivity and fat pipes, or if you need near real-time replication within a few seconds, by and large, is typically what you can expect. Note that this capability will tolerate a loss of connectivity. It's less tolerant of poor connectivity, right? It comes and goes, or it's flaky, or it's slow. That's harder to deal with. If you've got nice, good connectivity, but every once in a while it drops, it will tolerate that. Because of the batch nature, it'll go, oh, I don't have a destination yet. Well, if it comes back in 10 minutes or 20 or 30 minutes, it will just catch up at that point going forward, and then it'll achieve steady state, and off you go. Not great for, as I mentioned, high latency networks. If your data direction changes frequently, this may not be your best option. I mean, it'll work, but it's a real hassle for you. Solr doesn't really care. If you want to merge multiple collections into one, or if you want to split one collection into multiple, this may not be the best option. And if you have different schemas or configurations at either end, this may not be your best option. So for this particular use case, this is ideal. This is what CDCR was designed for, right? This particular crawl into, load data into A and copy it to B and DR. Perfect. So let's talk about streaming expressions. I wish I had 3 days to talk about streaming expressions because I think Joel Bernstein is a genius. And I love what it is. If you haven't heard about streaming expressions, read about it. It's, in my opinion, just my opinion, the most exciting, powerful capability to be added to a search environment in a really long time. And I can't really go into all of it, but it's awesome. So it is native in Solr. You don't need Fusion or anything else. It's built into Solr. Streaming expressions are pull-oriented, so you define it at the destination, at the target, and the target reaches out to the source and pulls the data in. So that's an important difference. But it can read from any Solr collection that you can access with a ZK host string and a collection name. And then it writes it to its local location. It is batch-oriented like CDCR, and it is runs on a timer like CDCR. It does a zillion things, not just this. This just happens to be one of the things, one of the thousands of things you can do with streaming expressions. So this is essentially how you would write it, and the way it works is these are like a stream of data flows, and you just wrap and wrap and wrap and wrap. And basically what this says is the topic expression queries data from this ZK host and this source collection name using a query string, filter queries if you need or want to. You tell it what field list, and you can tell it star, get all the fields if you want to. And then sort by, the sort is required. And then the Qt tells you how to pull the data. If you put in /select for the query type, it will get 10 documents and finish like any other select statement in Solr. The /export query style is designed specifically to pull everything. It doesn't stop at 10. It just sends everything that matches, no matter how many there are. And that's what Solr designed the export endpoint for, the request handler. So the topic query produces a list of results. And what's interesting about topic is that this checkpoint collection, it stores the high watermark of where how far it got, the version number last time it ran. And so when you call it again, it'll start there and get everything that has changed since then. Run it again, it'll get everything that's changed since then. So you get this really nice, ongoing, only what's changed capability. That gets wrapped up in an update, which is my local collection name. So this stream from some remote Solr gets turned into a sequence of documents across the wire, and it writes to this local collection in batches of whatever you specify. And then when that whole thing terminates, it wraps with a commit. And then what's cool is this daemon expression sets up a timer, and it says, okay, do that thing, but do it again every 5 seconds. And it creates an internal controlled sequence, and the ID, the unique ID you give it, allows you to then come back and go, oh, what's the status of it? What's the status of it? Oh, I need to stop it. Oh, I need to start it again. And you can see the interval, that's in milliseconds, so this would run every 5 seconds. And basically, because of the topic at the query at the bottom, it would, every 5 seconds, go fetch whatever's new, put it across the wire, commit it, update the local collection, force a commit, and go again. So, yes?
So, I see your FL has a star, but it only returns the ones that you have stored already or have docfile stacks.
Yes, so we're going to talk about that in just a second. This is best for selective replication when you don't necessarily need or want every field to come across. CDCR, it's the whole document. You don't get to pick and choose which fields you want. You don't get to pick and choose which documents you want. It sends everything all the time. With this, you have the ability with the field list to go, you know what, I only want fields A, B, and C, or where certain criteria are met. So this is good for selective replication, merge replication, split replication if you want to be selective about what you're moving and where you're putting it. And you can set up 10 of these to pick up different sections of the content and move them different places for whatever reason you might have. It is batch oriented, so it will also tolerate a loss of connectivity, and it'll just catch up once connectivity is restored. So it's not best for activate. That's just the way the slide worked out, but it's actually good for activate. Not best if you want a complete replica of the whole collection. I mean, it will do that, but if that's what you really need, I would say you might want to think about CDCR for that situation. It can only copy stored fields. So this is true of every Solr collection. If your schema says only certain fields are stored, then those are only the fields that are going to come back when you do a query. Well, this is based on a query. So if you need fields to be replicated that you didn't store, you're not going to get them on the other side. So location A is not necessarily going to completely match location B. Sometimes that's fine. Sometimes that's not fine, but this is one of the determiners of which strategy is going to be best for you. My assessment is this may not be the best choice if you're doing large-scale production replication. Again, I lean towards CDCR, but there's a lot of use cases where this is really useful. It is a little bit more difficult to monitor than CDCR is, and there is a potential for transport data loss. So I'm going to jump back here and say there's this topic query that pulls the data, and then there's the update piece that writes the data. Well, if the topic pulls it and it's writing to the checkpoint, right, high watermark, and then the update fails, there isn't a backflow mechanism that tells the topic, hey, back up your high watermark because I didn't get anything past 99. And I confirmed this with Joel Bernstein last night, and he said, yes, in fact, that is true, although I could fix that really quick. So he may, I don't know. Watch your update log. But if you're moving log data, it may be critical that you have every log line. It may not be critical that you have every log line. Right, that risk may be a showstopper for you. It may not matter. With signal data, like what I was dealing with, it was not a big deal. Right, you miss a few signals, you pick them up over the next few days, and it's no big deal. In your situation, it could be a big deal. Yes?
Quick question on that, the source checkpoint.
Mm-hmm.
Is that stored on the target? So if you had
Yeah.
multiple targets, they would each track their
Yeah.
own. And so then the source isn't encumbered with keeping track of more information
Right.
based upon what's going on.
That's right. Yeah, the checkpoint is on the target. Yep. Okay, so this is that use case, right? We've got multiple disparate signal collections trying to join into a larger master collection, and we want CDCR can't do that because you get collisions on version IDs. This one, it will do that happily. And for this use case, it was a great solution. Okay, the last one, parallel bulk loader option. How many Fusion users are there in the audience? And how many just Solr? Okay, so this is a Fusion option. It's called the parallel bulk loader. It's new in Fusion 4. Is that right, Emmerich? New in 4.1. It basically takes advantage of Spark. Anyone who's used Spark will know that Spark will load data from just about anywhere. Lots of data loader options. And what Lucidworks has added is a Spark SQL capability that allows Spark to treat Solr like a SQL data source, and you can select star from blank where, and it will load up that data. So essentially, using Spark, you can read from data source that has a ZK host string, load it up into Spark, write it to Solr data source that has a ZK host string, and Shazam, you've moved the data. I shouldn't say Shazam, it's not that easy, but effectively it does. And if you are interested in the capabilities that Spark libraries bring, like the machine learning libraries, like the graph libraries, like any of that sort of thing, then this is potentially a great solution because you can do some pretty amazing transformation in Spark. There's also an option to push to a Fusion pipeline, a Fusion indexing pipeline out of Spark. So another interesting capability. However, if all you're trying to do is move this exact record from A and get it to B, and you don't want to do anything to it, you just want to move it, this will work. It may or may not be your best option. This in Fusion is basically a picture of how you set it up. You need to know that these parameter names exist and what to set them to, but basically a collection name, a ZK host, and a list of fields, and then an output collection, and that pretty much sets it up. In Fusion, it can be a collection that's local to Fusion, or it can be a remote Solr cluster that you have configured in Fusion to point to. So what's it best for? It's best for high volume data transfer. It's really great if you need to use a Spark cluster to manipulate a large quantity of data at volume. It's great if you want to modify your collection contents, if you're changing data types, if you have data that can't be re-indexed and you need to move it someplace. So like log data isn't always recoverable because what you captured when it happened is what you got, right? And you don't get to go back and reread it. It's great if you want to run machine learning or NLP operations while you're processing the data. And it is actually, because it's in Fusion and it runs as a Fusion job, it's easier to monitor than a CDCR job would be. So streaming expressions are hardest to monitor. CDCR is a little bit easier to monitor. And these are even more easy to monitor. What is it not for? Apparently, it's not best for Activate. It's not best if you need a complete replica of a full collection. Again, because it's doing a query from Solr, you're only going to get stored fields. Even if you have indexed fields that have great data, you won't get the indexes. You only get the stored fields. Challenges, while it's easier to monitor, it's harder to configure. And so the use case for this might be to push down the aggregated, the master aggregations down into individual aggregations. In reality, CDCR turned out to be a better use for that. So to recap, Solr's CDCR, best for, like, if you need to just set it up and forget it and have it just run, use CDCR. It's robust, it's solid, it just works. If you need to replicate just your full collection as is, move it, great, use CDCR. Parallelized at the shard level, that's how it works. Solr streaming expressions, if you're doing partial replication, or you're doing split or merge replication, or, and you can tolerate the possibility, it's remote, it's very little sliver corner case, but the possibility that there could be some loss, Solr streaming expressions might be your answer. And the parallel bulk loader using Spark, it has a lot of transform options that are super powerful. And it can scale across compute nodes, which obviously, right, that's what Spark does. So those are, that's sort of the summary. Any questions?
So today we use Fusion 3.1.2 version.
3.1.2.
The Solr 6.2 or 5.
Mm-hmm.
So we have scenario we want to replica production to a DR.
Yep.
Exact same copy, same collection, same.
Yep.
So my question is, it's recommended to do it after business hours. Like, is there any overload to the production server when it pushes the data?
Well, obviously, there's not no load. So the question is, in a Fusion 3.1, Solr 6.2 environment, what's the cost of running CDCR from a processing standpoint? It's surprisingly light. Is that right, Amrit?
Yes. So, say 1,000 documents have been indexed to your source cluster. They will be sent to your target in a batches of 128, 256, whatever you provide. So basically, one or two extra threads are spawned inside single Solr servers, and they're very lightweight, and real-time replication happens. So you can do bulk loading, or you can do a normal indexing, and CDCR will just happen, take place in the background without anyone's notice.
So,
If there are any network connectivity issues or any problem occurs, is the error will be thrown out on the production servers?
if the question is if there's a network error, how will you know,
Yes.
and will it recover?
Yes.
The answer is if it fails to connect to the remote side, so that it waits, the timer pops, it goes, I need to gather whatever amount of data, I'm going to batch it up into batches of 100, 500, 1,000, 10,000, whatever you specify. It will attempt to, it just uses Solr J basically under the covers, so it's going to instantiate Solr J, it's going to try to connect to the other end and push to the CDCR endpoint. And if it can't, it will log that it failed, but it will remember that it failed and try again. Up to a certain threshold, it won't try for, do you know what the threshold is, Amrit?
So So it waits for 1 minute, if 1 minute, or until 1 minute or whatever time period you have provided, it's not able to make the connection. The CDCR process will halt it at that point, and whenever the connection is restored, all the pending documents will be sent across to the document. And there are monitoring APIs available, like ops, errors. So if you can go and check CDCR ops and refresh it again and again, you will see cumulative and consecutive errors happening at each target at your source. So it will, and those errors will be then categorized into bad errors, inter-server errors. So all those information will also be available at source.
Yes.
So this is pretty much, like the CDCR is really only advantageous to like a Solr cloud environment compared to like standalone server master-slave setup, right? I mean, any advantage to a standalone server using CDCR at all?
Not that I can think of.
Yeah, okay.
Yeah. A standalone Solr instance, turning on CDCR doesn't, I don't see how it helps you at all. Yes?
Two things. You didn't bring up a cloud or master-slave condition. CDCR
Is Solr Cloud only?
Solr Cloud only. So if I bring up replicas and using a Zookeeper cluster, same Zookeeper cluster for 2 data centers, it will be cross data center replication, or you don't?
I tried that once, and I thought, how clever am I to create a supercluster split across the country using a single Zookeeper ensemble, and it worked very badly.
Okay, it worked bad for us too. The second thing is, do you have any kind of best practices that shows us this much of an indexing, DPS or QPS, is best for this type of configuration for CDCR?
Based on QPS, I don't have a
Document per second.
documents per second.
Indexing load.
I don't have that number. Maybe Amrit, do you have like how many?
Yeah, so
What rate will it
working
support?
on this particular feature to like send the batches from source to target dynamics depending on the indexing rate. Fortunately, we have now metrics API in Solr 7. We want to leverage that. The best practice is to always have low schedule and small batches. Even if you're indexing at 10,000 documents per second, have it something like 5,000 at a CDCR level in 500 milliseconds, so that target is always caught up with your source. Obviously, configuring CDCR, introducing introduction to more resources. May you need 2 or 3 more threads at your hyper thread level at each server, and then more load is put upon each Solr server. So you need to make sure that EP is maintained, enough RAM is given to the servers and all that. But always good to have the same batch size to the indexing rate you have for your source. So that's the best practice, but we will try to make it dynamic, probably in 8.0.
Okay. 8.0.
Yeah, it will
This
take
is
time.
coming out, right?
8.0.
Next week, right?
Next Friday.
Take a while, maybe next, I don't know, like end of year, next year maybe, but yeah, we will try to get this in.
One more thing.
Yeah.
You use the same transaction log, right, for this CDCR. So you commit and it flushed to disk, and the transaction log, you get rid of it, basically, and your CDCR failed.
No, so in CDCR specific collections, transaction logs are not purged
Okay.
until they are forwarded to the target. Then
Okay.
they are purged.
So you keep track of that failure
Yes.
until that
Yeah.
part is done.
Yes.
And if you're having load problems getting all the data moved over, my recommendation would be that you increase the number of shards so that your shard count is larger and the contents of each shard is smaller, because again, CDCR operates at the shard level, so each shard basically is replicating itself to the other side alone, and so more shards means there's just less volume on each shard. Any other questions? Yes?
2 questions. One, you handle dynamically created connections. And the second is what happens under latency.
I'm sorry, what?
If you have latency issues.
Oh, latency issues, sure. So does CDCR handle dynamically created shards? As long,
And
Oh, collections. It can, if when you create the collection, the CDCR definition is in the Solr config.xml file. So if when you create your collection dynamically, it contains the CDCR configuration, and once it's created, you then execute the REST call that starts it, then yeah, it'll run. When you're in an environment that has latency, for the most part, it will run mostly. It really comes down to, can Solr J make the connection and move the data? What you run into in a latency environment is if you're running a CDCR batch every second, you need to clear the first batch in the second between the time it starts and the time the next one's going to go, right? So, and that's where latency is problematic. If it takes 3 seconds to make the connection and move the data, then either you need to back off your timer so that you have the right windows, but then you increase the batch sizes, right, because you're accumulating more data. Those are things you have to work out in your environment. Will it work in a slow environment? Yes, it will work. It doesn't work as well, is all.
The data loss, no loss of data still guaranteed.
Data transfer is guaranteed. Yep. And if it doesn't make it, and it can't get the confirmation back from the other side that it did make it, it's a handshake, right? Then it will log that it's an error, and it will stop until the situation can be resolved. Any other questions? One more.
Okay, we have a scenario very similar to your use case.
Uh-huh.
2 clusters instead of 3. Signals coming to each parallel cluster.
Okay.
And they want to be in sync for leveraging at boost time.
Yep.
My spy network is reporting that in latest Solr, the bidirectional CDCR, as long as it's not processing documents with the same ID, that you could have it working bidirectionally at the same time. Do you know anything about that?
Yeah. Could you set up CDCR so that data center A is pushing to B a certain set of documents, and data center B is pushing to A a certain set of documents with non-conflicting IDs?
Yes.
The answer is yes, you can. In theory, yes, that will work.
Okay.
Is there any ideal,
Yeah.
is there any ideal size for the shard? Like it's like,
Ideal size for a shard?
yeah, in terms of GB or binder, MB or?
No, because it gets into what's the document size, large or small, and
In terms of the shard size, can be go beyond 5 gig or 10 gig, or it should be?
sure, shards can get into hundreds of gigs easily. Yeah.
That's no.
There is no limit. That's
Yeah.
the cloud collection
Right.
property. Yeah, there's no. I don't think there's a limit.
Yeah, but there's a limit in terms of how fast you can search or how
Yeah.
fast
Yeah.
you can
Yes.
get.
Yeah, it becomes a hardware problem at that point.
Is the Solr streaming station can on node be your source and target? It's kind of bidirectional.
Yeah, you can do that. Sure. Sure, you can set it up to go both ways. Yeah.
The Spark option, while it's getting sophisticated in 4.1, you can still use it in 3.
Mm-hmm.
We've been using it. We tried all of the things. We settled down on Spark.
Okay.
The reason being, from bed bath and beyond e-commerce side.
Uh-huh.
So high traffic. We don't want to do anything on our query cluster. Just having sub queries.
Okay.
So everything happens on Spark cluster
Mm-hmm.
as data comes in.
Okay.
Spark cluster will have 3 different data centers.
Okay.
ZK string.
Uh-huh.
So it will just post in
parallel
Nice.
to different data.
Okay, that's a great solution.
Created the whole thing.
Yeah, that's great.
Because some of the challenges we ran into
Yeah.
other options.
So yeah, and if you didn't hear, they're using Spark as the ingest, as the starting ingest point, and then it distributes the content to multiple data centers using different ZK host strings. So that's great.
That just worked out better than
Yeah.
other options.
Sure. Perfect. Yes.
Quick question on, I guess, definitely the streaming expressions, but maybe even the smart one. Are they aware of deletes that have occurred? Because all they're doing are queries?
Yes. Well, they who? They.
Like the streaming expression, when it's just running a query on the source.
Yeah.
When something gets deleted from the source, how does the target's query know that something happened?
Excellent question. It doesn't. That's one of the limitations that you have to deal with. In that particular environment, with that mode, the deletes, yeah, you would have to have a solution for.
But if your source is basically a continuous appending, then
Yeah. Yeah.
well, with CDCR.
CDCR does handle deletes.
So Solr streaming is just to pull the data.
Yeah, that's right.
Are there any metrics available to check the status of the CDCR replication that both of them are in sync?
Are there metrics to guarantee that both sides are equal? Yes, there are.
Yeah, so there are 3 APIs available as of now. Operations, which will just tell you the forwarding rate of which the target is receiving the documents. Then you have something called queues, which will eventually tell how many documents needs to be processed for each target. That's 100 are left for target 1, 20 are left for target 2. Those kind of information are also there. And then you have errors API, which will show what are consecutive and cumulative errors occurring at each target at what time. Those targets and those errors will then be categorized into bad requests or internal server errors, etc.
Is that Fusion feature or Solr specific?
It's a
Solr.
CDCR feature.
Yeah.
As a monitoring.
Yes. And Fusion
Yep.
encapsulates Solr, so it's available in Fusion too.
Yeah.
So, I mean, you said ops and
Ops, errors, and queues.
Yeah.
Yeah, the Solr CDCR doc has the APIs doc.
Yeah. It's very well documented. Let's hear it for Emrit. Thank you.